Hey, hi everyone. Am I audible at the back? You can hear me, right? Cool. So, just a brief intro. Mm, hello. Yeah, cool. Hi everyone. Just a brief intro. I am Akshay. I work at Razorpay and mainly manage Razorpay.com site and all the infra related to that, right? So today we will be discussing about building an image component powered by Edge, right? So this is something which we are doing, did a sort of experiment for website, like for a few pages, and like we'll be sharing the learnings related to that. Cool. So let's talk about images, right? So web is like we talk about web as like hypertext, right? It's we use hypertext markup language, but web is extremely visual, right? If you uh, take this number for an account, like this is a data from Web Almanac uh, document, like it's does an annual survey to identify what's the current state of web. So 99% of the pages actually make at least one image request, right? So that's a lot. I mean, and almost every page makes some kind of image request, right? That could be even a simple fav icon request. So if you look at this graph, right? So this is from all the graph of all the image requests which is made on the Razorpay.com website. So you can see that on an average, there is what uh, 24K images, right? And at peak, like it's around 46K images in a single day. So that's a lot. I mean, since images are of a significant count on a page, right? They also have a significant impact. They impact your core web vitals, your user experience, and SEO. Like from a user experience point of view, if you are using unoptimized images on your site, right, it will load slow. It will give a perceived slow load speed to the end user. And from a SEO point of view, if you're not optimizing images, then your site search engine ranking will definitely get affected, right? And we will look web vitals in detail, like in the coming slides, right? So in images impact significantly your LCP. This is an example like which I pulled from Razorpay POS page and the pricing pages. So in this example, you can see that the image is marked in red, right? So that's actually flagged as an LCP image. What LCP means is something which takes the most amount of time to render on that page, right? So images are generally the one which come at the last. So if you optimize your images, you can significantly boost up your LCP numbers, right? And under web vital which images impact our CLS, right? So let's say you're reading an article on some page and suddenly an image loads up, right? Due to that, your text content gets shifted entirely itself, and this is a poor user experience, and no one wants this, right? So this mainly happens because we as a developers sometimes don't use proper height and width on our images, which results in a CLS, right? So let's see like what are the challenges with image handling, right? So one important one is format selection. There are like a lot of formats to go around with. So and for optimization we have to follow particular patterns, right? And responsiveness. Then further it's image loading techniques like progressive image loading, lazy loading, all that. Then further, it's optimizing image delivery for the user, right? So let's start with format selection. We will cover all the others in the following slides, right? So with format selection, we have n number of image formats out there. Like these are some of the image formats which you might be using on a daily basis, right? It's JPG, PNG, and SVG. Then there are some image formats which are the new and upcoming modern image formats. That's like WebP, AWIF, and JPG XL. Like some of them don't have a very good browser support. Like I don't think JPG XL has a support in like any of the major browsers at all. AWIF is quite up and coming up, and WebP is the one which has the most browser support from this three modern image formats actually, right? So using them is not that straightforward. For now, let's focus on WebP and AWIF mainly, or let's simplify it and focus on WebP only, right? So we might think, okay, so what's that? Like it's simple, right? I can go ahead and use like a cool.webp and like I'm able to load webp images in my browser, right? But for majority of the people out there, like who are on older browsers, right? They don't have a proper webp codec within that browser. So because of that, it will result in this error occurred while loading the resource, and they are not even able to see that single image. So that's why like using WebP in a simple image tag is won't work, right? So what's the solution? Like you can the traditional way is to go about using a picture tag, like right? In a picture tag, you will specify the source src set, like you will specify multiple sources. One would be your JPG image, which will act as a fallback. And if the browser is not supporting WebP, it will load your JPG image, right? This is the traditional approach. But yeah, what if ever I want to use that image as a CSS background, right? So for that, again, I have to use some JS library like this modernizer JS, which will detect if my browser is supporting WebP. We can programmatically add that WebP is supported. So we will inject a class like .webp, as you can see here, and the WebP image will be loaded. If no WebP is there, the JPG image will be loaded, right? But this is not easy to work with. I mean, developers have to think a lot, like adding fallbacks, like adding extra markup. By the way, just maybe a quick show of hands, like if anyone has actually used Modernizer for implementing WebP images. Hmm, I guess much people haven't used it because it's not a great developer experience to go about, right? And it's this traditional approach lets you to add a lot of markup, and it's a lot of manual work for the developers, right? So what we can do is let's move it out from the code to where like we can move it to the edge, right? So let's discuss like what this edge is about and deep dive into it. So before we understand edge further, right? Let's understand what a CDN is actually. Edge is closely linked to CDN in this particular case, right? Any of you who have experience or work with any CDNs? Cool. I can see a couple of hands. Nice. Cool. So this is just an example like of how a CDN generally helps with asset loading, right? So let's say my images are in a S3 bucket in Mumbai, and my users are in a completely different part of the country. So the request has to travel throughout the country, right? So this is not a very good thing for your latencies. Like images need to be loaded as fast as possible, right? So that's where CDN comes in. Like here in this example, I'm taking AWS CloudFront as an example. In so what will happen is all the subsequent requests will be cached in the CDN, and it won't have to travel till the origin. And CDN is distributed throughout the country. Like there are lots of CDN point of presence locations in the country, and like this way we can easily scale up our image delivery, right? Let's take a closer look into it. So with CDN, you will also get capability to execute some logic at the CDN. So that is called edge computing, right? You are executing logic closer to your users. And in AWS ecosystem, there is a service called AWS CloudFront Functions. So which does this edge computing actually. And Edge has a lot of point of presence throughout the world, right? So we can rest assured that if our content or we are using CDN for image delivery, right? Then it will be delivered to the users very fast. So we will be using CDN very deeply in our architecture. So let's dive into this architecture diagram. Before I'm taking this as a small example, so we will take this cute cat example and understand how we can implement format selection at Edge. So when the developers upload any image, right? So what we will be doing is we will pre-process that image, right? So developers has uploaded this JPEG in the S3 bucket. At that time, we will have to run a pre-process step, which is like one-time step to pre-process the image to JPEG from JPG to WebP and AVIF formats, right? Now let's look at the other part of our architecture. One would be our AWS CloudFront, which is our CDN. Then comes our edge computing solution called AWS CloudFront Functions. And let's say a user requests an image. This is jpeg, and it will go to our CloudFront function first, right? At present, we are not adding any logic in our CloudFront function. So it will directly pass to the AWS CloudFront, and from the CDN, it will go to the current image as we have requested for the JPG image, right? Cool. This works in this doesn't actually solve anything at present. So let's see what we can add further, right? So okay, just a second. Yeah, I think I skipped that. I don't think this is visible at all. Uh, Yeah, so when an image request is made by the browser, right? So it actually sends a couple of headers, which we will be using for format selection. So if we look at this header, request header, which is sent by browser, we can see there is something called accept, right? So this is accept header, which the browser sends. Inside this, I'm not sure how visible it is, but it's written image slash AVIF and image slash WebP. So that means this browser is capable to decode your WebP and AVIF images, right? So now we can dynamically get data from our users that which image is supported in their browsers. So let's use this data in our edge. So what we will be doing with this is, let's say I want to request a WebP image for this particular one, right? So I just added a query parameter format is equal to WebP to explicitly specify that I want a WebP image if that is supported by the user's browser. In my CloudFront function, what I will do is I will rewrite the request object to .webp image if that is supported by the accept header in the user's browser, right? So now what will happen is instead of going to the .jpg image, the request will go to the .webp image. So this is how we can dynamically get WebP images without adding extra markup at the component level, right? And if we look at this simple code, in Edge you can execute a function. Like it's just a simple function which gets the current request, and inside the request, I'm just checking if the format is equal to WebP is mentioned in the query string, right? At that time, okay, yeah. If format is equal to WebP is included in the query string, right? We are checking if the accept header contains image slash WebP. If image slash WebP is present, we are just appending .webp at the end, and the further request will go to the WebP image which is stored in our S3 bucket. So this is how dynamic image selection happens at the edge. We can further easily scale up this to support AVIF as well. Let's convert that static format is equal to WebP to format is equal to auto, and just change this part of the code, right? And for AVIF, what I'm doing is just again a simple string match. If image slash AVIF is present, add .avif at the end of the image URL. Cool. So maybe let's see a demo as well for this. Yeah. So if I open this particular image in my browser, right, and inside networks, I have to refresh the page to see the headers again. I'm on slow 3G. Okay, why am I on slow 3G, man? Just give me a second. So that image is loaded. Okay, yeah, it's there. I was wondering why it stopped working in demo. So in this, you can see that the particular image, uh, there is a accept header in the request. In request, we can see like we are sending the accept header, right? And the edge actually processes this and changes the URL to send us back the WebP image. Now, how do we know that this is the WebP image, right? So we can see that by inspecting the content type header. Okay, so since I have the code to send back AWIF as well, right? And my browser obviously supports AWIF. So I'm getting back image slash AWIF here. So that's cool, like, right? So let's jump back to our slides actually. So now with this, we have a better developer experience and a better UX as well. If we provide users with low, like a correct format images, right? And one important thing which I guess we should have seen is what's the actual difference between file size, right? So if I remove this format is equal to auto, the actual image will be loaded, right? So we can see that the actual file was around what 1.2 MBs and the converted AWIF image is around 398 KBs, right? So that's a significant difference between the file sizes. So this clearly shows like if we go with the modern image formats like WebP and AWIF, like there will be a definitely better improvement in our user experiences. And with deciding this at the Lambda, things become much more simpler for our developers, right? They can easily uh, just add the image URL with format is equal to auto and latest image will be served for them. That's it. Nothing else need to be done. And in recent years, like if we check the 2021 Web Almanac data, it shows that the AWIF adoption has increased quite a bit. So I hope like if we simplify our developer tools to increase or make using images more easier, right, with modern formats, this will definitely go further for AWIF. Cool. So since we have already solved uh, optimizing images with correct formats, right? Now let's look into responsive images. So if our site is responsive, then should be our images, right? So for that, what we can do is uh, we solve these two main problems, right? And there is art direction type of images and resolution switch images. So first, let's see what is art direction type of images. So if you look at this image, right, you can see that we can see a person standing there, and on the mobile version, we can see that the image is actually cropped to the person, like to keep them in focus, right? So art direction is actually keeping the important part in focus when the images switch from one screen resolution to another, right? So art direction can't really be solved at the edge levels because of this important part, right? We can't really define like what's important, like until and unless you add complex machine learning thing to define like face detection or something, you can't do that. So mainly traditional approach is to go via adding SRC sets for images um, to show up on different screens like this. Like it's a bit of manual process, right? So we will mainly focus on resolution switching. Like this, actually, we can optimize significantly in Edge. What resolution switching actually means is it's serving same size image, but with different file size, right? So if you are seeing the image in a desktop environment and you are seeing the image in mobile, the file or the image file which is shown on mobile will be very smaller compared to the one in desktop. Since you don't have to have additional pixel data right there. Uh, so yeah, we can do this optimization in Lambda. And but the traditional way to go around this is adding image SRC sets and sizes and let browsers do their job for this, right? So, to, yeah, sure. Uh, just second. For resolution switching, what we are actually doing is we will convert the images into multiple formats actually, like from 1 pixel to let's say 2048 pixels, right? And all these are pre-processed and added to the HD bucket. In HD bucket, once all these images are added, our infra components again remains the same. Like we will have the CloudFront function, and when a user requests for an image, right? Let's say they request for a 1 pixel image, that request will go to CloudFront, where we will rewrite the request to the 1 pixel image actually, and further the 1 pixel image will be served to the end user. Cool. So I will cover the demo. Like there is one more demo as well. So we'll club those two, like a bit short on time actually. So another problem which we can solve is since we have discussed about resolution switching and all, right? Now let's see about image loading techniques. Like there are mainly two image loading techniques, that is progressive image loading and lazy loading. So with progressive image loading, what actually happens is we load the lower quality image, uh, like which you can see on the right hand side. That's an example of Google Photos, where the lower quality image is first loaded and the actual image loads up. Or you can see the image here, which is from Pinterest. On Pinterest, they actually load the dominant color and then switch it with the actual image, right? So we can actually implement this with the images which we pre-process during our resolution switching, right? Let's see a quick demo and we can wrap very quickly. So just a second. Cool. So let's check out this. So if we go into the network tab, right, this is a small example where I have a couple of images, and you can already see that very first image, right? So this is just a 1 pixel image, which is uh, which is shown initially, and when this particular image comes into the viewport, right, at that time we will swap it with the actual one. So this is comparable to the Pinterest example which we saw earlier, right? So how do we know it's a 1 pixel image? We can see in the inspect that it says, yeah, 1 pixel size. Yes. And what happens if I scroll further down? So I've enabled image filter inside this. So we will be able to see image request in network tab, right? So it requested for the actual image and it will be swapped further, right? So yeah, here it is. We have our progressive loading. And if we set the default image as what, 8 pixels, then we will get a preview of that image. Like it just gives users some idea that this type of image is there, right? And further, if we increase the quality, right, from 8 to 64, the experiences differ. Like I'm just scrolling to show you different image loading experiences. And all this is easily done by simply swapping the image with different size, which was pre-processed earlier in the Lambda, right? Now let's go back to our slides. What we can do further now for image optimization. There is called client hints. So client hints is something which will tell the Lambda about the user's device and network conditions actually. So what is it like? It doesn't make much sense. So how do we go about even using it, right? So if you add the simple meta tag, like it says accept ch, and there is few content that is density pixel ratio, width, and viewport. So what does it will do is when a particular image request is made, in the browser will automatically send certain data to the server, or in our case it's the edge. So you can see that there is this header SECCH viewport width added, right? So it just means the viewport width of the user's device, and we can further use this data in our edge to decide which type of image to be served to the user. Further, like just listed down all the client syncs which are commonly used, like that you can see downlink here and save data. Those are a bit interesting. Like if the users have save data enabled on their device, right? At that time, this save data will be marked true, and you can send a very low quality image to them so that the site loading feels faster on such devices. So, what's the key takeaways from this, right? So, if we simplify the usage of images on web, right, by using the platform to its full potential, the platform isn't actually limited to your browsers. Like browsers are sending a lot of data in headers, which we can further leverage into optimizing image delivery and our assets further, right? And if we simplify the developer experience, then it will help us in building a good user experiences as well. And we can obviously make web more accessible to people by adapting to their device or their network conditions. Thanks a lot. So that's a wrap.